Here is something almost every engineer has said at some point: I was never good at math. And here is what I want you to hear right now: that is almost certainly a teaching problem, not an ability problem. Most of us were taught math in the worst possible way: memorize formulas, pass tests, never once understand why any of it works. That approach fails. Every time. And it is not your fault. Today we fix the method. There are two ways to approach mathematics. The academic approach says, start with formal proofs and work upward from axioms. The engineering approach says, start with a picture, build intuition, then reach for the formula when you need it. Every video in Phase 1 follows the engineering approach. We show you the visual meaning first. We code the concept before we prove it. And we always ask, what is this actually doing, in plain English, and why does it matter for AI? 3 principles will govern how you learn throughout this series. Principle 1: Intuition before formulas. Every concept has a geometric or physical meaning. Find that meaning first. The formula is just compressed notation for something you already understand. Principle 2: Build, do not memorize. Implement every concept in Python. When you write gradient descent from scratch, the chain rule stops being abstract. It becomes a loop you debugged. Principle 3: Struggle is the signal. If something feels hard, that is not a sign you are not smart. That discomfort is your brain building new structure. Sit with it. Sketch it. It is working. Here is the exact toolkit we will use across Phase 1. Manim, a Python library for mathematical animations. Every visual in this series is built with Manim, and you will be able to run all of it yourself. Jupyter Notebook, run code cell by cell and see what changes. NumPy, the foundation for all numerical computing in Python. Linear algebra, matrix operations, gradient calculations, all of it runs through NumPy. Pencil and paper, non-negotiable. Writing by hand builds memory in a way screens never will. And 3 Blue 1 Brown, watch his Essence of Linear Algebra and Essence of Calculus series alongside Phase 1. His visual approach is the perfect companion to what we build here. Now let me give you the daily system. 25 to 30 minutes per day. That is all. Step 1. Watch the video without taking notes. Let the concept land. Step 2. Close the laptop and sketch the key idea in your notebook from memory. Step 3. Open Jupyter and implement it in Python. If you cannot code it, you do not understand it yet, and that is the work. Step 4. Write 2 or 3 sentences in plain English explaining what you learned. No jargon. If you can explain it simply, you own it. Consistency beats intensity. 25 minutes every day will take you further than 4 hours once a week. The key takeaway from this video: math is learnable. The method is everything. You do not need to be born a mathematician. You need the right approach: intuition first, implementation second, and struggle as the signal. Before the next video, do 3 things. Install Manim, Jupyter, and NumPy. Remove every friction point now. Get a dedicated math notebook. And come back for video 4, which is where Module 2 begins and the real mathematics starts. Introduction to Vectors. With pictures, code, and everything you need to actually understand it. Module 1 is now complete. You understand why math matters, what math is involved, and exactly how to learn it. That is already more than most people starting an AI journey ever get. Subscribe so video 4 is waiting for you. Hit the like button if today changed how you think about mathematics. And if you know someone who has been putting off learning AI because math feels scary, share this video with them right now. I will see you in video 4. The real journey starts now.